Okay, so moving right along here, we're going to be covering how do we actually measure the subcooling in a refrigeration system. And what's going to be really interesting, if you understand the basics of how to do superheat on the evaporator side, it's going to be pretty easy to do the subcooling on the condenser side because it's a very, very simple process, or excuse me, very similar process. All right, so here's our little illustration of our condenser. I've just grabbed just that so we can kind of see what's happening here. So as we did on the superheat side, we're going to take a temperature measurement first. And where that temperature measurement comes from is on the outlet of your condenser. After we went into gas, it comes out as a high pressure liquid here. We are going to take a physical line temperature of this liquid line here, they call it. So the material, as we covered before, is the same thing as it is on the evaporator side. This is typically going to be made of copper. And you want to make sure that you use your probe from your temperature device. And you want to make sure you properly attach it to that copper tube. And you want to make sure you insulate it. So in other words, you want to make absolutely sure that your probe is only seeing the physical line temperature, not the ambient air that also surrounds your probe, right? You can usually do that with a little piece of insulation. A lot of times the manufacturers of the probes will give you a special Velcro little package you can wrap around it to make sure you isolate it. But you have to make sure it's properly isolated, insulated. The other thing too, as I mentioned before you ever get into doing diagnostics of subcooling or superheat for that matter, you want to make sure that your thermometer has been properly calibrated. And as I mentioned before, just get a styrofoam cup. You want to fill it about half full of water, half full of ice. The smaller the cubes, the better. And you want to let it sit for a few minutes. Drop your probe in there and make sure you're reading exactly 32 degrees Fahrenheit. Usually, as I mentioned, they have a calibration port, usually a little screw that you can, a pot that you can change and calibrate your meter. I've seen many cases where technicians are taken off in the entirely wrong direction simply by not having the right calibration on their thermometers or their gauge set for that matter. So make sure you get that. So for our illustration here, we're figuring 87 degrees. So we're reading 87 degrees physical line temperature. So really what that means is the liquid refrigerant that's inside that pipe is 87 degrees. All right, so that's going to be a valuable piece of information to have. So the next thing we're going to do is we're going to take a pressure reading. So like we did before over on the superheat side, or the evaporator side of the system, we're going to take a pressure reading. And again, as we touched on before, this is a real fancy manifold or refrigeration gauge set. And we're just going to assume for right now that we're not using it to calculate our subcooling. We're going to do it the old-fashioned way. So this, just for our example here, we're reading 230 psi on this side of the system, because this is the higher pressure side of the system, because it's on the compressor side. So that's totally normal. All right. So what we're going to do here, the next thing is we're going to take a look at our temperature pressure relationship chart. As I mentioned before, you can download these from the manufacturer of the refrigerant's website. A lot of times it's printed on the back of the box because a 25-pound jug of this stuff comes in a box, and you can get your temperature pressure relationship off there. But you always want to make sure that you know what refrigerant you're working with. The best place to find out that is to look at the machine's nomenclature tag, because if the tag is still there in good shape, you'll be able to see what refrigerant that system is running. And you need to make sure when you're taking your when you're converting your pressures to temperatures, you want to make sure you're dealing with the right refrigerant, because it can vary a lot, right? So what I've done here is this particular refrigerant, we've got 230 psi. So the refrigerant that we're using, just as an example, we've got a 97 degree translation. So at 230 psi, the pressure the TP chart tells us that that pressure should be 80, that temperature should be 87 degrees F, right? You'll notice there's a difference here, right? Okay, so what we're going to do here is we're going to do our calculations. So how we do it is we take the condenser inlet temperature, the condenser inlet pressure, and we're going to convert that to temperature, which we did up here, and we're going to subtract that from the physical line temperature right here. So in this case, 97 minus 87 is 10 degrees F. Now what is that, right? So if you remember in the last in this lecture, we said that subcooling is the additional heat removed from the liquefied refrigerant. So this makes perfect sense, right? So you have 97 degrees, that is the converted temperature of that refrigerant, but we've actually dropped it 10 additional degrees F, and that factor is our subcooling. So that tells us that our condenser has removed an additional 10 degrees after this state change has occurred, right? So that's pretty much it. We're going to get into some more details about the with the value of superheat, subcooling, measuring it, and we're going to actually get into some interesting information on diagnostics using superheat and subcooling.